Well, good day, everyone. My name is Bradley Needham. I'm here to discuss some intermediate Swift. We're going to be talking about a lot of different items over the course of this next hour. So hopefully you'll learn a little bit, and please feel free to ask any questions along the way. I will try to spot them. Sometimes I don't see them right away, but I should be able to get back to them. And hopefully at the end of the time here, I'll have a few minutes to go ahead and answer any of the questions that maybe I missed, or if you have something at the end that you wanted to get answered for you. So let's go ahead and get started here. And what we're going to be looking at today, so we're going to be really kind of focused on building custom types. And what are the mechanisms in Swift that allow us to build custom types. So we're going to look at structures, we'll look at classes, and we'll look at protocols. And within each of those, we'll discuss things like methods, fields, initialization, and inheritance, and how that works. Okay. I do have an early question here, and yes, the question is, will there be a recording available? Yes, we will post a recording of this webcast on the Developmentor website after it's complete. And also, it's a good question to bring up, because the other thing that we can also do, and I will put there right now, is that everything I type in the demo here as I'm doing it, we will put up on GitHub, and I'm going to place in the chat here a link to the GitHub, so you can go ahead and download that, and that'll probably be, I'll have it up, just at least, give me an hour. It probably will take like 5 minutes, but at some point after this webinar, I will go ahead and put up all of the code that we actually go over during the webinar. Okay. All right, so let's go ahead and get started. So like I said, we're going to do fields, methods, initialization, start with classes, structures, and protocols, and really, again, focusing on building custom types and see how those fit together in Swift, and how we can leverage these types of constructs. So the first one I want to get into is, if we're building a custom type, really, normally what we're looking together is to aggregate some fields together, some variables together. We have a lot of primitive types in Swift. We know we have integer, we have double, we have string, and we can create arrays, and we can create maps, and you can really do a lot of stuff with that. But sometimes to make your code cleaner and more understandable, we want to use our own types of groupings of particular specialized structures that provide the bits of information that we might want to have. So let's try initially to create a little structure here. So we do that using the struct keyword. And in Xcode here, Xcode will go ahead and give me a little Intellisense to help me type some of this in. So I'm just going to type over here, and let's create just a two-dimensional point, something that represents a two-dimensional point. And it gives me this little section of where I'm going to put the properties and the methods. And I'm going to start off just by putting properties in there. And we define the properties, or the fields in the same way that we would variables at a global scope or inside a function, just by simply specifying them with var, and the name that we're going to use. Now I can simply put something like 0.0 and var y and 0.0. And we know in Swift uses type inference to figure out that these are going to be doubles according to what I've assigned them to. And just like regular variables, I can also, put in the type itself, basically specify that this is going to be a double, to be explicit about it. But again, I don't need that, as long as I can infer the type to the one that I'm looking for. So then how might we use this point? I can again create a variable of it, type. And point is what I'm going to create. And when I print out the values here, I can use a print line and basically say, the x equals, and use string interpolation, right? We've used this string interpolation before. P.x and y equals P.y. And if I run this, I should get out a build succeed. And then of course there's 0.0. Now, some of the things we might want to do with this type. So this is, just kind of a straight aggregate type. And one of the things that we're going to discuss and keep in mind here is that classes do something very similar. in the fact that we can group these fields together, and structures allow us to group fields together. The main difference between a class and a struct is that a struct in Swift is what is known as a value type. And by it being a value type, that means much like integers or doubles, or even arrays and maps in Swift, when they're passed around from function to function, you get a copy of it. You basically get a new copy of all the data that is associated with that particular item. So it's important to note that because classes act very differently than that, and we're going to see that in just a minute. So let's see how a structure acts when we pass it to a function, and see how we can also then add member functions that may or may not change some of the internal state of a structure itself. So first, let's say we wanted to have a function like a scale function. So to create a function in Swift, I say func, right? Specify that I'm creating a function, and I give it a name, so scale. And then I'm going to create a parameter list of some sort, right? So the first thing that I want to put in here is, because I happen to be scaling a point, I'm going to say that the name of my first parameter is point, and it's going to be of type point. And the name of my second parameter is going to be by, let's say, because I'm going to scale by a particular value, and that's going to be a double. Now, so far, notice I haven't provided a return value, and when we don't return values in Swift, we get, a void return value, right? This is equivalent. You can do this in Swift, say that you're not returning anything, but for right now, I'm going to leave off a return value, and then we're going to have to add one in just a minute, and we'll see why. So first off, I want to scale this point. So I might say, all right, so the x value, if I want to scale it, point times equal the by value, right? And I actually want to get the x, the particular point. So the x portion of this, and then down here, I might want to have the y version of this, right? But one of the things that I said was that when items are passed to functions which are of structure type, remember the structure types are value types, and that means that I'm actually getting an entire copy of this structure. So if I invoke the scale function down here on my existing point, and let's actually add some values to the x and the y, because 0 times 0 is, or 0 times anything is always going to be 0, right? So let's make this 1.0, and let's say p.y equals 3.0. And then let's call the scale function here. Get down here where you can see it. Scale, and I'm going to pass in the point, which is p, and then I'm going to pass it in, and we'll scale it by 2, each one. Well, we have this error here. And so even though we're invoking it, we're saying what's going to happen is when we invoke this scale function, we're actually going to get a copy of p. So the memory here that's associated with p will actually be copied into this function. And one of the things that happens with parameters in Swift is that by default, Swift parameters are constants. So it's equivalent to doing that, right? We know we can use var for variables, and we can use let for constants. So the default of a parameter to a function in Swift is let, which is a const. So we think, okay, well, the first problem here is that, of course, point can't be changed. So these errors here that are occurring are probably because this is a constant. So let's go ahead and change that. We can basically specify it as var. And this says, yeah, okay, so now this is var. So we want to manipulate and change the variable that's passed in here. And we do that. We seems like the errors have gone away, allow me to actually change the values that are being passed in. But since, like I said, this actual type is a by value type, since we're getting a copy, when point is actually a copy of p, we're going to see no change according to this function call. So let's go ahead and run it and see what happens. Build succeeded, and our return value, of course, is basically the starting point, right? 1 and 3. We were expecting to see maybe 2 and 6 after we scaled by 2, and we didn't get that. Even though I've cleared up the errors, we've got to keep in mind that structures are always passed by value. And just to show you, let's do a little change here. We'll talk about class a little later. But let me run this like this, okay? Notice the difference. Simply all I did was change from structure, right? Everything else I could do the same. I could create a class, I can add properties to it, and I can pass them into this function and manipulate them. But notice the difference between using a class here and a struct here. Using a class here, I get the 2.0 and the 6.0. I actually get a modification. No other change. Notice the compiler doesn't tell me that anything is going to be different. It simply compiles and runs it, and I get completely different behavior. Let's see. I have a question here. Let's just find out what it is. All right. So this is a question about internal and explicit or internal and external names, or not quite, just the var function. So I'm going to answer this question. So this question is just the question about the second parameter. You notice that I didn't specify var on the second parameter. And the reason why I didn't specify var on the second parameter is because it's fine for this to be a let. Notice that the by parameter that I'm using here is only being used on the right-hand side of the equation, which means that doesn't need to change its value, and so therefore it's fine for it to be a constant. I could make it a var, wouldn't really make a difference because I'm not trying to change the value internally. Okay, all right. So let's go ahead and remove that. The let is fine in that question. Okay. So this is interesting, right? Behavior. So we know that we get this pass by value. So we got to keep track of that when we're dealing with structures. We know that structures are by value types. But another thing we want to do here is that, yeah, it's great to be able to take and create a new type like point and have it group these variables together. But that really doesn't give us, kind of full power of the point. We still have to have these, kind of these external functions like scale and maybe rotate and stretch or some other types of things that we might want to do, especially if we start dealing with a larger thing rather than just a two-dimensional point, right? There might be a shape or something we want to add to. So we have to have some way of maybe integrating the behavior, the scaling function, with the type itself. And that's where methods come in. So these are properties, right? The properties are their associated basically variable types that are in part of the structure. And we also want to now have member functions, or basically methods. So what we want to do is we want to take this function itself and actually make it part of the point itself, so that when we invoke it, we can invoke it directly on a particular point that we're trying to scale. When we do this, one of the things we don't actually need is this first parameter, but I'm not going to take it out just yet because I want to kind of show you some of the differences that can occur with it being as the parameter list as associated with methods versus global functions. So the first thing is it's a method, and since it's a method, that means we actually invoke it using the dot operator here. Basically, we take a object of type point and we can invoke it using the dot operator. And notice there's still an error here, and let's have a look at what this error is. Now, this error comes up in the difference in Swift between what are called internal parameter names and external parameter names. In Swift, we have two choices. We can have all of our parameters not have to specify their names, and the parameter names that we use are just the ones that we use basically internal to the code, right? Example here in my scale function, I use the value point. That's my internal parameter name. In by here, I'm using the name by here internally to my function. With global functions, if I move this back out here to a global function again, with global functions, the rule is, I'll take this off, that every parameter only has an internal name by default. So by default, I don't have to specify the name. It's just something that I use in here. So when I invoke, notice when I'm invoking the function here, the scale function, I'm just passing the parameters. I'm not specifying what their names are. You can, however, do what's called an external name, and you can force it either by simply stating it, right? So now I have my by here external and my by here external. I can't use the same ones. I can use, just make this X here for right now. And what happens is that now that forces me to have to actually specify the parameter name when I invoke the function. So this is an external name. I specify it before my internal name. And if I want to use the same name, I simply put in a hash, right? So my hash says here, and then that way it says that I have an external name and an internal name, and my external name is the same as my internal name when I use it. So again, just the default here for global functions is that they are always internal by default, meaning you don't have to specify them as internal and external. With methods, the rules are a little different. With a method, the first parameter is given as an internal name only, and the second and every subsequent parameter after that is as an internal and external name. So basically has an external name that's specified in this case. So notice down here, when I invoke this, when I switched it from a global function to a member function, or to a method, from a bear function to a method, I actually had to specify by, right? This becomes an external name. But notice again, the first parameter still has not become an external name. It can still be internal. And that's the only reason I left this parameter still up there, because ultimately we're not going to use this parameter now that we've made it a member function. Now that we made it a member function, the point that we are associating with this particular function call is now the special keyword self. So I'm going to delete this parameter. I'm going to change point here to self, right? And down here to self. And what that says is that in this member function, or in this method, I'm going to actually affect the object that happens to be on the left-hand side of the dot. All right, so again, my call changes down here to scale. I no longer need the first parameter. And now what happened here was that the by changed from a external parameter to just an internal parameter, because it's basically the first parameter, right? The first parameters are available. So if I want to have it as an external and internal parameter, again, we talked about that, I can put the hash sign. So if I put that pound sign here, then this basically says that this is now an internal external parameter. We can see on line 26 down here that that is now cleared up. There's no error. We now have a new error though. And what is this error? This error is basically the same as the error we had before we specified the point parameter as being able to be changed, right? It was by default, it's a let, right? When the parameter comes in. And same with self. By default, self comes in as a let for structures, right? It comes in as a constant. And the way that we don't really have a parameter here, self, so we can't say var self anywhere to kind of change the mutatability of the self portion of the structure. So in order to do that with functions and structures, in Swift, there you have a keyword called mutating. And mutating basically says that, okay, that is equivalent to saying var self, right? Making the self portion of this function call, which happens to be the left-hand side of the dot operator, making that mutating or changeable, right? So let's go ahead and now rerun this. And we get actually the behavior we expected with the with the same type of behavior we got with the class when we passed it as a parameter, because this is actually, we're not making a copy of P in this case, right? We're using this variable, this point, and actually mutating it by the fact that this function is mutating allows us to change the value of self. Okay. So that's the base of structures, right? And the main, the thing that we got to think about is this mutating with structures. And the reason why is that whenever we pass a structure, whenever we create a structure and we pass it to a function, that value is going to be passed by value, right? It's not going to be passed by reference, which we're going to look at right now when we talk about classes. The other thing really to take away and understand here is the difference between methods and bare functions, right? Bare functions give us the default for the parameters are always internal parameter only. You can specify it to be different. You can add external parameters if you want, but the default is internal parameter. And for methods, it's different. The first parameter is a internal parameter, but all subsequent parameters by default are given external names. And I have a question here of, does Swift provide garbage collection? In a sense, yes. So there's not say like a generational garbage collector like you would have in something like Java. But what Swift uses is automatic reference counting. And I'm not going to go in too much detail over that, but that really has to do with very much like, basically incrementing every time you create an instance of a class, every time you pass a class to a function and you create a new reference to it, it's going to bump that reference count. And then every time you get rid of that particular variable, it's going to bump it back down. And then when you no longer have any strong references to it, it's going to let it go. It's going to free up the memory there. We can run into cycles there. And there's two keywords in Swift that I'll probably talk about in a later webcast, where use called weak and unowned. And that's where you can specify the particular type of reference that you want to use to try to break some of the cycles that could occur with automatic reference counting. Okay. All right, so let's go on to structures. So here's go on to classes. So we've talked about structures. I'm going to copy this. I don't want to, I'm going to just comment it all out and put it below us so that you'll have it at the end of the webcast and be able to look at those values. Clear out I'm in here, check there's another question I saw popped up. And let me just So I missed the difference between a method and a bare function. Is it just the diff and parameters? It is. So for the parameter list, it is basically the difference in the parameters. The other difference between a method and a bare function is that the method must be invoked right with the variable type. So if I had var p, equals a point, and then I say p dot, right? So it basically has the by 4.0, right? It basically this ends up being the self parameter when you invoke a method. Okay. The other one is just kind of the whether these parameters are internal and external. The other one is that it's related to a particular class, and that'll be the same with structures or class as we use either one of those. So let me go here to class, and let's create a class, and let's create a class like Apple. All right, and this is going to have a weight, and that's going to be equal to, say, default weight of 1.0, and then I'm going to have a var redness, and that'll probably be a double as well of some sort. I'll just pick these for the fruits. Let me see, I have another question here. You got that one. Okay. All right, good. All right, so here's our class. So the difference here again is the by reference parameter. Now classes can have, just like structures, very similar. They can also have methods. So let's create a function and let's call it, I don't know, byte. Or we could use grow. How about here? Grow. And with grow, we want to pass some water. And that may be a double, some amount of water, and food. That may be some soil or some amount as well. So we can use double. I mean, I could create other types here, but just to show us that we have a value. And then we could basically add to the weight. The weight can grow, plus equal the water times the food, or something to that effect. We'll have some way of making it grow. Now notice here in the member function, I could also still, just real quick, we do get the recording at the end of the webcast. Okay, so here's we'll post it on the DM website. So here with the weight, notice that this is blue. The Intellisense has told me that this is actually a field of the Apple type. How did I make it explicit? Right, this is the same. I can say self.weight, or I can say just weight, and I get the same behavior here. In this case, then I can create an apple. So var a equals apple, and I can have it have, so by default, right, we know if we print out these values, we get the, let's put that in the a dot weight, and the a dot redness. If I print out those, of course I get the default set values of 1.1, and I can then do something like a dot grow and add some water here and some food. notice what happened again with the food was that by default, it gave me this, as I use the Intellisense, it gave me this fact that this happens to be a external name, and this first one is just a internal name. Okay? And that's just the way that the methods work. So now if I print this again, so copy and paste that, copy and paste that, then of course I run it again, and I should get a change to the actual apple as I used it. Now, here's the difference, one of the differences to classes versus structures. So if I take a bare function, and let's call it eat, and eat is going to take an apple as its parameter, and it's going to eat maybe just a portion of it. So it's going to subtract, you know, a little bit from the weight that happens to be there. So we're going to say apple dot weight minus equal, say 0.5 here. I remove some of the weight from it. I got to put a 0.5, sorry, 0.5, specify it as what it is. Okay, so now if I go ahead and eat the apple, so let's put down here after this one, let's eat a piece of it. So eat, again, it's a bare function, eat, we pass in the apple that we're talking about. And then I'm going to go here and print the weight and the redness again. And we'll rerun this one. Notice the differing behavior from if this was a structure to if it was a class. Even though this is still what? The default for a parameter to a function is still let. So apple is constant, but apple being constant only means that this reference itself is constant, so that I can't do something like apple equals and try to have it equal a new apple, like change the value of the variable itself. Cannot assign to that value. I can, however, change the internal state. And that's very different as soon as I change this to a value type like struct. Right, struct. Okay, just back to just the name here, apple. If I try and run this one, again, this immediately, the weight is not changeable. And do we remember why this one is a problem? Because if you're going to actually have it mutate, you're going to have to call it mutating. So let's change it back to class. All right, class apple, everything else should go fine. We rerun it and we should get the same behavior of these things, changing the internal values. Okay. All right, so classes and structures look very similar, right? You have fields or properties, and you have member functions or methods that you can provide on them. But their base difference is that one is a value type and one is a reference type. And a reference type means that all you're doing is passing around that same exact object, just using different names for it, right? The name here is now apple instead of the name being A, which is where it was initially at this scope, okay? And for structures, it's different where you pass around a value, meaning that this becomes the new structure type, a complete copy of it, okay? All right, so let's go ahead and move on and let's comment this part out. And let's talk a little bit about initialization of these two. And actually, why don't I'm going to go back down, and I will, let me move this down and we'll look at the point structure again and talk a little bit. There's one other kind of major difference here between structures and classes. I'm going to put this commented down here, and I'm going to uncomment this section. We use our structure again. Okay. All right. Get it back where we can see it easier. Okay. So here's our structure, and if we run our code again, that should just print out our expected behavior, the change, the mutating scaling function. But one of the other things about creating these points is, notice I went to the trouble of basically creating the point and then providing the different values for it. Real quick, another question here. Is there equivalent of static members? Members are common. Yes, there is. There is static and there's also class. So there's two keywords. There's the static keyword you use with structures and the class keyword you use with class. They're fairly equivalent though. I'm not going to go into too much detail about them in this particular lecture, but yes, you do have them. Okay. So the difference here is for the initialization is that when I create the point, I don't want to always have to be breaking apart. Like, what if there's a bunch of fields? And also, what if I forget one? What if I forget to initialize one? It was really important to actually be initialized. Well, with a structure, by default, you actually get a initialization, basically an initialization function that exists for the structure type. So when I actually create this structure type, I didn't have to actually put in this X and Y. And I'm going to go ahead and comment these out. I don't want to delete them so you guys have them in your code later. But if I put in here, and you can see in the Intellisense even, when I put together the, try to create an instance of a point, I get two choices, right? I get the choice of the one that I was using, which was just an empty parameter list, or I get the choice of one that has explicitly listed out for me an X and a Y value. So if I hit tab here, I can put the 1.0 and hit tab here and put the 3.0 for the next value in the X and Y. And so this basically initializes this to the same values as if I had done it the other way by putting it here with the initializing each eternal one. Now for a class, if I change this again to class, so again, just one other difference between struct and classes, the first problem we see, the first difference we see here is that this keyword makes no sense when dealing with a class. There's no need to add the mutating specifier to a function when dealing with a class, because a class is always mutating because it's by reference. You can change the value, right? It's only the reference itself that becomes constant. So this is, there's no issue. They're not passed by value. So that's the first thing that we see with class. But the second thing we notice, if I got rid of that error, is that this no longer works. And that's because with structures, I get the initialization for free, basically because that initialization routine is generated according to the list of fields that I specify in my structure. So whatever fields I specify in my structure, I get an initialization function. So let me go back to the struct way of doing it, where it exists, and let's type out what that initialization routine would look like. So with initialization routines, they're not really member functions. They're kind of a specialized construct, but they look very similar to functions. The difference is, of course, is there's no func keyword. You don't use the func to specify them. You say init, right? And you give it this name init, and you can provide these parameters. So parameter here is I'm going to say X is a double and Y is a double. And then what I'm going to do, of course, is self.x equals x and self.y equals y. Right. And this here, this construct from line 15 down to line 18, that's basically what I got for free simply by declaring this as a structure and providing these two fields at the top. So basically starting to ending here. So now if that's that structure, what do you think will happen if I go ahead and change this back to class? Class, of course, we have to pull off the mutating, right? Because the mutating is the one thing that doesn't make any sense there. And sure enough, everything else is clean. If I rerun this, build succeeds and it goes cleanly, because now I have explicitly provided this initialization routine for the class type, because the class type doesn't get that initialization routine for free. Okay. All right, so that's the main difference here. Let's go ahead and I'm going to put back the mutating, and I'm going to put this back as struct. And let's go ahead and comment this out again and move on to the next bit here. All right. So let's get a little space here so we can see what's going on, clear out the output, and then we'll start up again. Clear this down. Okay, out of the way. So let's look at where we're at and what we've been talking about. All right, I have one question here. I'll go ahead and select the question here before it. And the question is, would you get an error if there was a var z and you didn't include it in the init? So yes and no. So it depends on what you're doing. And let's actually explore that question real quickly here, because it's an important concept here. Let's put this back, do our uncomment this section, and let's have a look. So let's say we don't have the init, right? And this is a structure, so this is fine. I get the initialization routine for free, so everything's still compiling here. But let's change this and not add default values. So I'm just going to specify double. So notice I have just specified simply that this type here, right, is going to be of type double, right? But I haven't given it a initial value, right? Now notice everything is still working, and that's because I'm using this initialization routine that I got for free here. So if I come and I take this and we comment this one out, and we try to do the one that simply takes no parameters, right? What's going to happen is the compiler is going to complain that these two values are not actually going to be initialized. So if I don't have values for these, then it will complain. If I do have values for them, then the compiler will just use the default values. And this is going to work the same in the sense for classes as it will for for other things, right? Okay, so this is going to be basically, the same type of construct if I do this with a class, is that these values have to be initialized totally in the initialization routines in order for things to be completed, okay? So I'll go ahead and let's go back. I think that clears that up. All right. Okay. Just put this back and commented, and we're back here to start. So let's look at what we've covered. So we've talked about structures, we've talked about classes. We haven't got to protocols yet. We're going to talk about protocols right now, but we've seen how we got fields and methods, and we've looked at initialization. So just before we go to protocols, let's discuss inheritance, because inheritance is really what protocols allow us to exploit, right? Basically the power of inheritance, which is really type compatibility, which allows us to write generic code using these structures and classes. So first off, with inheritance, base inheritance between classes only works between classes. And what I mean by that is that structures cannot inherit from other structures. So if I took a structure, say struct, and I call it shape, and shape has a function on it called draw, and it doesn't return anything, and basically print line draw shape. And the reason I want to have this structure here is not because it makes any sense really to have something that simply draws itself by saying draw shape, right? But because it's abstract, right? It's a generic thing, which means I could write a generic function like function render, and render could take an array of shapes as its parameter, and then render could do something like, for s in shapes, s dot draw, and could run through and render whatever this picture happens to be, which is an array of shapes. Now, the whole point of being able to do that is so that I could do things like var, here's my array of shapes, and inside this array of shapes, put things like, instead of just a shape and another shape, I want to put things like concrete ones, circle, line, maybe a rectangle or something. So in order for that to work, I have to have some sort of object that is type compatible with shape. And how do we do that? We do that through inheritance. So if I said struct circle inherits from shape, and then tried to override, right, this, sorry, the Intellisense is getting out of hand here. And have this one basically, let's copy and paste this, go a little faster. Draw a circle. You know, this would give me this generic behavior, right? This rendering use of inheritance. In Swift, this won't work, all right? And the reason why is there is no inheritance between structure types. Structures cannot inherit from other structures. So how do I change this to make this work the way I want to now is I can make this a class. And let's copy and paste this and make a line here too. I've done my, so then of course the other fix here is, since I am doing this, I am overriding. I have to specify that that's what I'm doing. And this is just a safety check to make sure that I have overridden the correct signature in the inheritance hierarchy that I'm using. So now this is clean, and I can then of course render what I want. So I didn't do that rendering, so let's call render. And let's pass our array of shapes. And we'll run it again. And we get our expected behavior, which is draw shape, draw shape, draw circle, draw line. Okay. So the important point is, of course, inheritance can be done in Swift, but can only be done between classes. And you can only inherit from one other class, right? I cannot have another class up here, class of something that simply says print. And then expect to be able to somehow also make this type of that class type as well. You can only inherit from one direction. So how do we fix that? Well, if we think about this, and this kind of leads us into then protocols, is that really printable is not a base class, right? Printable is more of just a grouping of methods. We want to have the print method. There may be some other method. And when we really have this draw method here, this draw method really isn't something that should be just necessarily associated with shape, but really maybe something that's called drawable. It's a drawable type, right? And these are really just, there doesn't make any sense for an implementation, right? This kind of default to saying print, that doesn't really help me. In order to actually do the printable type, you need some more information associated with the actual concrete type, the circle, the line, the rectangle, whatever happens to be the printable type. So it doesn't make sense to even have an implementation for these functions. Just like the drawable one here, it doesn't make any sense to have any implementation for these. But yet, given that these are classes, I have to have implementations for them. So in Swift, this is known in other languages as interfaces. In Swift, we have what are called protocols. And a protocol is really built for, in the object-oriented programming world, of being able to do this, being able to write a bit of generic code, right, that is written in terms of a more general type or an abstract type. And that abstract type is what we need these, our subtypes to be able to be converted to. And the protocol can have basically a group of methods, right? It tries to put together a group of methods that are necessary for doing this particular operation. So a couple of things that change then when you start using protocols, and when you conform to a protocol, you're not really inheriting, you're not becoming something. So therefore we aren't really overriding, we're actually providing implementations. So the first thing is, of course, these are now protocols. Got to change this one to drawable. This is drawable. And it's no longer actually overriding, we're actually implementing it. So you don't have to put the override keyword here. In this sense, to actually live up to both of these protocols, Circle needs to also provide the method signatures that are in printable. So one way to let Xcode do some of that for you is if you just start typing the name of the function, right? So here's the method print, and then I hit return here. Notice that the Intellisense gives me most of the typing done for me, and then I can go ahead and print line, print circle. Right, get that spaced out a little bit. And then let's say that maybe line just does drawable. Maybe line is not printable. So we draw a line, shape no longer exists. Let's just put in a circle and a line. And then let's specify though here, first let's get rid of the override. Okay. Now this last error here is because the type, the inferred type, because these are two different types, and say line only supports drawable and circle supports drawable and printable, the compiler can't really easily do type inference to tell that what you're really trying to create here is an array of drawable, right? So it defaults back to this ins array, which is an Objective-C type that exists. So what we really want to do is basically tell it, oh, what we're trying to do here is create an array of drawable, right? Specify to the compiler, this is the actual type that I want to be using in this, so that when I call the render function, it will be typed with the correct type being passed in here. So go ahead and run it. And we get our draw, and we could do the same with a print if we wanted to, the print type. Okay. Another thing about protocols, just so you can actually add, so protocols are not just grouping of methods. I can put in a grouping of method here to support the generic code that I want, but I can also put in properties. So I can say var, name or something for it. I have to specify the type. So this is going to be a string type. And then I need to specify what are the types of things that you can do with this. So I can just say get, that makes it a read-only property. Or I can say get and set, and that'll make it a read-write property. So if I make it a read-only property, of course, in order for Circle to live up to that protocol now, notice we got the error here because the protocol has changed. It does not conform to printable. I need to add some way of having a type that supports a read-only property. Now, it doesn't matter that this can actually be a read-write property. Notice this property is actually a read-write property because it's a value property that exists. But when dealing with it through the printable protocol, right, you cannot you cannot set or change it. You can set it, change it if you're actually using a circle, because there may be another type that supports strictly a read-only type. And I could certainly do that with what's called a computed property over here. A computed property means that I can specify it like this and simply use, say, a function return circle, which means that this is now totally a read-only property. It still lives up to the printable protocol because that's all it expects is a read-only value. If I change the printable protocol to expect a set, this will now break the circle because it won't be able to use that type. Okay. All right, let's go back. Let's see where we're at. This, I think we've got this running again. Should be build succeeded. It runs, does our draw circle, draw line. So pretty much we've gone through most of what we wanted to cover here in building the custom types. We looked at structures, classes. Again, the main thing to remember, the main differences between those two, structures are value types, which means that when you pass them to functions and move them around, you actually get copies of those structures. By default, if you use a let, if you make them constant, you cannot change any portion, any internal portion of that structure. By making it constant, you make the entire thing constant. And that's why we have to have specify particular methods that might make changes to a structure as mutable. Classes, however, are reference types. So when you pass them around, you don't actually get copies of them. You simply get new names for the actual type that happen to exist. There's no need for mutating because when you make a constant reference to something, it's only the reference that is constant, right? The object itself can still be mutated by using the dot operator, by invoking a function or setting the properties to something different. Protocols, then of course, protocols exist as groupings of methods and properties. Basically, protocols are contracts, right? They allow people to write frameworks like our render function that can be written in generic terms, and then still we're able to expand the objects that actually live up to and support those operations and pass new types to the generic code that continues to use the protocol. So again, we looked at the initialization using the init function. And again, there are several other things that are, again, if we moved on to more advanced topics and more stuff about classes, there's still stuff out there. The questions on static, right? And what type of static variables and static methods are supported. There's also access modifiers. Access modifiers are really specified on a field level, not a field level, or specified on a file level. So the access modifier itself affects how the things are consumed according to the particular file, and then the module. So again, there's other things we can look at. And then, of course, inheritance, you can inherit only through classes, inherit implementation, but protocols kind of give us a lightweight inheritance and a way to do multiple inheritance where we can support and live up to multiple different types of protocols that are out there. All right, so let me see if there are any questions. Feel free to ask other questions if you want. Other than that, I don't have anything else for the lecture. So I hope you've enjoyed the session, and we'll wait here a minute for some other questions, and then otherwise we'll go ahead and shut it down. Okay, so again, hope you enjoyed the session. Hopefully it was useful, and we'll see you again when the next section comes up. Thanks a lot. We'll talk to you guys later.